All right, you guys are welcome to today's class. In this lesson, I will be discussing the laws of logarithm. Okay, we'll be looking at the laws of logarithm. Please, if you're online, I just put your name at the comment section. Just write your name beneath. If you are Timothy, just write Timothy. Okay, so we'll be looking at the laws of logarithm. Okay, if you have done logarithm before and then you do not understand it, so I actually need you to pay attention, because after this lesson you will no longer be scared of any problem coming from logarithm. If you understand the laws of logarithm, the basic laws of logarithm, no, you won't have any issue with problems coming from logarithm itself. Just the same way indices has its own laws, that's how you also have laws in logarithm. Okay, so let us look at the various laws, the very important laws in logarithm. Number one law we'll be talking about is the addition law. Addition law. Addition law of logarithm, what is it saying? Addition law of logarithm says if you have two logs like this, let's say log x base a plus log x base a, right? Let me even use b here, or let me use y. If you have two logarithm like this, logarithm of the same base, remember the bases must be the same. Look at this, log x base a, and this one is also what? Base a. So long the base are the same, it is the same as, I can express this as this log a, then I will multiply these two numbers together, whatever I say, these variables, that is xy. That is addition law of logarithm. Addition law of logarithm. If you have something like this, if you have two logarithm of the same base, it is the same as picking one of the logarithm and then you multiply the two. Another law of logarithm we'll be looking at is the subtraction law. Subtraction law is almost the same as the addition law of logarithm. The difference is that while you are doing addition in the addition law, this case you will be seeing something like subtraction. So it means if you have logarithm to its own logarithm of the same base, let's say base x, log x base a minus log y base a, in this case is the same as picking one of the log and then you divide this, that is x over y. So this you can express it as this. That is subtraction law. Don't worry, I will explain all of the laws and then I will bring out examples that we will start applying these laws to. Okay, another law is logarithm to its own base is 1. Take note, logarithm, another law is logarithm to its own base is 1, is equals to 1. What does that mean? If you have a log like this, log x base x, okay, according to this law now, everything here is equals to what? 1. So long it is to its own base, x, log x base x, logarithm to its own base is equal to 1. There's another law of the logarithm of throwing back of power. Logarithm of throwing back of power. Now look at this. It means if you have something like this, log x, and there's a power of 2 here, let me say log x base a, and there's a power of let me say b here. According to this law of logarithm throwing back of power, it means this power I can bring it back here like this, so it becomes b log x base a. So this and this, they are the same, and if I can write this as this, also means I can write this one as this. That means I can also decide to bring this one here, or let's say I have something like this initially, x log y base b. I can decide to bring this x here. If I can throw it back, I can also take it up. Okay, so it means I can also write this as log y, bringing it back, x base what? A. Law of throwing back of power. Another law that addresses the power of the base. Okay, what if you have a base that has a power? Let's say for instance you have something like log x base y raised to power a. Okay, how do you address the power of this base? To address the power of this base, now you can take this base a to this place, but when it's coming here, it becomes the reciprocal. Reciprocal of anything means 1 over that thing. So when a is coming back, it will not be 1 over a log x base y. The same thing if I have something like this. If I have something like log 2 raised to power 3, okay, log 4 base 2 raised to power 3. I can take this 3 here, which is the power of the base, to this place, but when it's coming to this place, it becomes the reciprocal of 1 over 3. So that this simple laws I have explained, let us solve some examples and see how this laws finds application in problems. example and see how we can apply the basic laws to solve this problem. Okay, solution. Now look at this. Remember the law that says that when you have two bases, two logs of the same base, if you observe this question, it's having base 10, base 10. Okay, it says I can pick one of the base 10, and multiply this on this and this. That is 4 times 25. So this is equals to what? Log base 10. If you multiply this, it gives me 100. All right, I will not stop here because I know there is something I can still do to this log 100 base 10. I can still break it down further. If you notice, 100 is the same as 10 raised to the power of what? 2. The reason why I'm doing this is because I want to make this log to be the same, this log to be the same as what? This base. So I already know that if I raise 10 to the power of 2, it will give me 100. So instead of leaving this 100 here, why not just make it 10 raised to the power of 2, so that I would have something like log 10 raised to the power 2 base 10. All right, remember the law that says that you can throw back the power of a log to this place. I can bring back this. Get out. I can bring back this. So if I'm bringing it back, it will now be what? 2 log 10 base 10. Okay, remember the law that also says that logarithm to its own base is what? 1. Since logarithm to its own base is 1, it means the whole of this is equals to 1. So I have this to be 2 times 1, which is equals to what? 2. So the solution to this problem is what? 2. That you understand the first example I did, I want you to solve this and put your answer at the comment section. Here's another example before us. So how do we simplify or evaluate this logarithm? Let us go. It's very simple. Let me put solution here. Now, how do I go about this? Firstly, let us try to break this 16 down, these values. Let us break them down, okay? Let's just break it down. You see, 16 is the same as 2 raised to the power of 4. Since 16 is the same as 2 raised to the power of 4, we can also break 32 to the what? 2 raised to the power of 5. Okay? Remember the law that says that you can throw back the power of logarithm to this place. So it means I can bring this 5 to this place. It becomes, from bringing the 5, it becomes 4 log 2. At the same time, I can bring back this 5 to this place. If I bring the 4 here, it becomes 4 log 2. I can bring this 5 to this place. It becomes 5 log 2. Now you can see this log 2 and this is log 2. They can cancel out. So if they cancel out, I am left with 4 over 5. That is my answer. That is my answer. If you understand the example I just did myself, you solve this one and put your answer at the comment section. Because of logarithm, let us simplify this problem we have before us. How do we go about this? Okay, let's see what we can do here. Remember the law that says that if you have two logarithms, addition of two logarithms, okay, two logarithms to the same base, you just what? You have to multiply them, okay? And if this is minus, that means this one will now be division, okay? So what are we going to do? Before we apply that logarithm, we must look for a way to remove these 2 from this place. And how do we do that? We can bring it back to be this, to be the power of this 5. You know, there's a law I already explained that, you know, allows us to do something like that, perform that operation. So first of all, let us bring this 2 to become the power of this 5, so that I will now have something like log 5 raised to power 2 plus log 36 minus log 9. After I have done that, what is 5 raised to power 2? It is 25 plus log 36 minus log 9. Okay, I can now apply that addition law. I can apply both addition law and what? Subtraction law to this addition law here and subtraction law here, so that I now have something like log 25 times what? Log 25 times 36. Because of this addition, I turn this what? To multiplication. Remember, I can also apply the subtraction law here. So it means this will now be divided by what? 9. Okay? So if you solve this, it gives you what? Let us solve this and see what we will get. Let's just reduce. 3 can go here 3 times. 3 can go here. It will give you what? Just, I think, 12 times. So we are left with what? 25. We are left with log 25 times 12, all divided by what? 3. 3 can go here once, 3 can go here. How many times? Can go 4 times. So we are left with log 25 times 4. And log 25 times 4 is equals to what? 25 times 4 is 100. And we have this to be equals to what? 100 is the same as 10 raised to the power of 2. Now, let me tell you something. Whenever you see logarithm that does not, there's no base. You can see there's no base here. If there's no base, it is simply base 10. So it means we are having base 10 here. If there's no base, it is base 10. Okay? So knowing fully well that this is base 10, I can bring back this power according to that law. Now you understand. So if I bring back the power, I have something like 2 log 10 base what? 10. Remember, logarithm to its own base is 1. So it means 10 log 10 base 10 will give me what? 1. So I have this to be what? 2 times 1, and everything is equal to 2. Problem here to solve. Still applying the laws of logarithm. Now, if you notice, this one is quite different from the examples we have been solving. Now, this is look at the difference here. Look at this. We are having a decimal number here. So if I were you, the first thing I do is to convert that decimal number to a fraction. If you have been following my videos, I have already explained how you change a decimal number to a fraction. How do we do that? For those that were in the class, please just do it and drop the comment section before I do it myself. Just pause this video and drop your answer at the comment section before I actually do it for you. Okay, for those that don't understand, look at how you simply do it. Now look at it. Bring this log 2 base 8 minus, I told you, if you are converting any number, any decimal number to fraction, all you need to do is assume that you are not seeing this point here. And if you are actually not seeing the point, what are you seeing? You are seeing 25. Let us assume the point is not there. We are seeing what? 25. So put the 25 up all over. Right? I told you this point to change to 1, this order, this you put it to 0, this one you change to 0. So it means if you press your calculator, 0.25 is the same as 25 divided by 100. But of course, you will not live like this. It's actually very important that you simplify. I mean, you reduce this fraction. And if you are reducing this fraction, 25 can go how many times? 1 times. 25 go how many times? That's 4 times. So in reality, 1 over 4, if you press calculator, it's still the same thing as 0.25. So instead of 0.25, why not just put 1 over 4 here? Okay? Plus log 32 base 8. So what are we going to do next? It's very simple. Okay, look at this. We can apply division law. You can see this is minus, and we can simply apply our division law. You see all these logarithms, they are to the same base 8, base 8, base 8. So we can apply division law here, and whatever answer we get, we now apply our addition law here. It gives us our answer directly. So look at it here. If we apply division, it means we are picking log base 8, then these 2 divide by whatever we have here, 1 over 4. Okay, addition law, multiplication. So we're having this to what? 32. Remember, this is it. So if you simplify this further, we have something like 2 times this 32 will give us 64 all over. Please, instead of this divide by, I want to use this so that we will not be confused. Remember, we still have log base 8. So for this other 1 over 4, I will just put divide by 1 over 4. All right. So this will now be equal to log base 8. Now 64. This division, I can turn into multiplication, and when I'm changing it to multiplication, this denominator goes up and this comes down. So you have it to be what? 4 over 1. So in reality, we're having this to be equal to log 64. As it is now, I can solve this by, I'm trying to make whatever I say and this to be the same. Okay, you see, if I raise this to the power of 8, there's this 4 here. If I multiply 8 times 4, it will not be, it will change it from being the same with the base. So what do I do? What if I do it like this? I have 64. 64 is the same as 2 raised to the power of 6, right? And 4 is the same as 2 raised to the power of 2. And 8, I can also express 8 as 2 raised to the power of 3. So that I have this to be equal to, if I apply the law of indices here, they are the same base. I pick one of the base, I add the power, that is 6 plus 2, which is 8. Remember, I still have this denominator here, 2 raised to the power of 3. So this is equals to what? Remember, I can throw back this power to this place. If I throw back this power to this place, I am left with 8 log 2. Then I still have 2 raised to the power of 3, right? The next thing I will do now is to throw back this power. And if I'm throwing back, it becomes the reciprocal like what we did before. So this becomes 1 over 3 times 8 log 2 base 2, right? So this becomes what? Now look at this. Log 2 base 2, the whole of this would be 1. So if the whole of this is 1, what do I have left? I'm having 1 over 3 multiplied by 8 times 1. So everything becomes what? 1 times 8 times 1 will give us 8 all over 3. So that is our final answer. 8 over 3 is our final answer.